This is Leo Santos, and this is the Project 1, less hard version. So I started by drawing what the problem would look like, the ramp, the vector, and it's 10 meters above the ground. And the slope was given to us as dz ds equals 1/12. And I started with the vector notation, x of s, y sub s, and z sub s. And since dz ds equals 1/12, I took the integral, and so z equals s/12. And this is what would describe the y axis, with the amplitude being 1. So y equals sine pi over 60s. And this is the vector written with the y sub s and the z sub s substituted, and we want to find the x of s. So we know that the magnitude of r prime of s equals 1, which is the arc length parameter. So 1 squared equals the magnitude of this, and then we square it and solve it out until we find an x prime of s. And then to find the change of x, you just take the integral from 0 to 120. And I put that on Wolfram alpha, and it said 119.58. And so, I forgot to mention, I used a double angle formula to convert this to this, to make it a little bit easier for me. And there's like a sideways illustration of it. So this would be change of z, which equals 10. This would be change of x, which is 119. And sorry if this is not focusing. But then we do a Pythagorean theorem, and we get b, which is a straight line distance, is 119.16. So this is question 1. And this is question 2. I was going to do it this version with k being the magnitude of t prime of s, but it was a mess, so I switched to this k equals r prime cross product r double prime, magnitude of that over the magnitude of r prime cubed. So we get r prime is 119s if we substitute the number we got, number 1. Then r double prime is that. And so we substitute r prime, r double prime, and the magnitude of r prime into this, and we get this. And I put in the Wolfram alpha min and max calculator, and it gave me this number at the period. So that's the project. Thank you.